Now, let's take a quick look at a slightly odd-looking long division problem. Let's say we were doing long division, and we divided 4002 by 24. When we set up our division bracket, of course we'll have our 24 outside, our 4002 inside. 24 goes into 40 one time. 24 goes into 160. Let's see. Here's this awkward guessing that we don't have to do with polynomials. 28, 16. Okay, 7 was too big. Let's try 6. Okay. 24 goes into 160 6 times. Into 162 still 6 times. And then a remainder of 18. Okay. Why am I looking at this problem? Well, this problem has something in it that turns out to make our lives complicated when we're doing polynomial division. And it's the fact that there are zeros. The polynomial long division problem that we could think of as like analogous to this somehow is 4x to the third plus 2 divided by 2x plus 4. Right? Thinking about the place values as x's instead of 10s. These problems are somehow analogous. But well in the whole number case, we had these placeholder zeros, and those zeros had an important role to play in the long division. In the polynomial case, we typically don't need to write down that we have 0x squared plus 0x. When we do long division, we need to write in placeholder zeros. So when we set up our division bracket for this problem, we write our 4x to the third, then we write a 0x squared and a 0x, and then we actually have a constant, the plus 2. This way, when we do our division, again looking only at the first term, 2x goes into 4x to the third. Well, 4 divided by 2 is 2. X to the third divided by x is x squared. We have our 2x squared times 2x plus 4. 4x to the third plus 8x squared. And notice we now have somewhere to write our 8x squared. If we didn't have that 0 placeholder, there would be no like term to write the 8x squared underneath. 4x to the third plus 8x squared. Now we subtract. 4x to the third minus 4x to the third is 0. 0x squared minus 8x squared. Well, 0 minus 8 is negative 8x squared. Okay. Now we bring down the next term. Notice the next term happens to be a 0. So we'll have plus 0x. Divide, looking only at the first terms. 2x goes into negative 8x squared. Well, negative 8 divided by 2 is negative 4. X squared divided by x is x. We'll have our negative 4x times 2x plus 4 will be negative 8x minus negative 8x squared minus 16x. Negative 8x squared minus 16x. Okay, subtract again. 0x minus negative 16x. That's the same as plus positive. So that's positive 16x. And bring down the 2. One more round of division. 2x goes into 16x. Well, 16 divided by 2 is 8. X divided by x is just 1. I don't have to write that out. So I've got 8 times 2x plus 4. That'll be 16x plus 32. So 2 minus 32, that's negative 30. My remainder will be negative 30. So my division gave me 2x squared minus 4x plus 8, remainder 30, negative. So the key point here, we need to fill in the placeholder zeros. Here's another example of something that can go wrong with this sort of polynomial long division. Let's say we wanted to divide these two polynomials. The thing that you'll notice about my dividend here is that the terms are not in any particular order. Right, you'll see that the x squared term comes after the x term, the x cubed term comes at the end. When we set up polynomial long division, we can't have that. Why not? Because the procedure for polynomial long division relies on the terms being written in order to keep everything organized. When we set up our polynomial long division, we have to write our terms in what's called descending order, so that the highest power of the variable comes first. So we'll write our 4x to the third first, and then our 3x squared, and then our 2x, and then our negative 8 inside our division bracket. Outside our division bracket, we'll have our x squared, and then our negative x, and then our 1. So our divisor happened to already be in descending order. Okay, now this works just like before. We're looking only at the first term. 4x cubed divided by x squared. 4 divided by 1 is 4. X cubed divided by x squared is just x. So we'll have 4x times x squared plus negative x plus 1. So that'll be 4x cubed plus negative 4x squared plus 4x. 4x cubed plus negative 4x squared plus 4x. 4x cubed minus 4x cubed, of course, is 0. 3x squared minus negative 4x squared is minus negative is the same as plus positive, so 7x squared. Two x minus 4x is negative 2x. And now we bring down the last term. X squared into 7x squared. 7 divided by 1 is 7. X squared divided by x squared is just 1, so we don't need to write anything. We'll have our 7 times x squared plus negative x plus 1, 7x squared plus negative 7x plus 7, and one last round of subtraction. 7x squared minus 7x squared is 0. Negative 2x minus negative 7x, that's the same as plus positive 7x, is 5x. Negative 8 minus 7, that's negative 15. So my remainder is 5x minus 15. I got 4x plus 7, remainder 5x minus 15. Notice here my remainder was not just a number, it had an x in it. Which brings us to the very last complication. What can our remainder look like? Our remainder can be anything it wants as long as it is of lower degree than the divisor. Right, so my divisor had an x squared in it. My remainder can have an x in it, but not an x squared. And that's the last thing that we need to be aware of as we're doing polynomial long division.